Wilhelm Röntgen. Experiments started as soon as the discovery of X-rays was made in 1895. Röntgen actually discovered X-rays by accident when an image was shown from his cathode ray generator. He later discovered that the rays generated a point of contact where they penetrated many types of matter. A week later, the first X-ray was made at the hand of Röntgen's wife. Röntgen named these images X-radiation, X being for unknown. Polish physicist Marie Curie actually conducted the first treatments of cancer using radioactive substances such as uranium, polonium, and radium. During World War I, as director of the Red Cross Radiological Service, Curie worked to develop small, mobile X-ray units that would be able to diagnose injuries near the battlefront. Thankfully, on October 1914, the machines were ready. Sadly, due to overexposure to radiation, Curie was diagnosed with pernicious anemia and on 1934, she passed. What is nuclear medicine? Nuclear medicine involves the use of small amounts of radioactive materials to help diagnose and treat a variety of diseases. 14% of all radiation in the world is from nuclear medicine. Benefits include that nuclear medicine is used in many ways, like in nuclear imaging techniques. They give doctors another way to look inside the human body. The techniques combine the use of computers, detectors, and radioactive substances. These techniques include the positive emission tomography, which is a scan that examines your body's chemistry and its functions. Other techniques are single photon emission computed tomography, bone scanning, and cardiovascular imaging. Nuclear medicine imaging is useful in detecting tumors, aneurysms, blood cell disorders, and many more disorders. Nuclear medicine monitoring basically means that patients exposed to radiation from nuclear imaging are closely monitored. A huge risk of nuclear medicine include too much radiation. CT scans and nuclear imaging accounted for 3/4 of radiation exposure, with nuclear stress tests, also known as myocardial perfusion imaging, identified as the procedure accounting for the largest single radiation exposure. An estimated 27% of all cancers in the US are caused by radiation exposure from CT-related imaging alone. As many as 4 million adults in the US under the age of 65 are being exposed to high potentially cancer-causing levels of radiation from medical imaging tests. There are devices such as the digital area monitors, which are monitors with built-in GM gamma detector that provides continuous gamma radiation monitoring. These monitors cost around $1,870. Currently, the Minnesota Post posted an article titled "Unnecessary Medical Radiation Driving Up U.S. Cancer Rates." These types of imaging can be life-saving, but they can also be dangerous. Some tests deliver a high dose of ionizing radiation, which is associated with the increased risk of developing cancer in the future. The National Cancer Institute estimates that CT scans that were conducted in 2007 will cause 29,000 of excess cancer cases and 14,500 excesses of deaths due to cancer. Some questions you might want to think before receiving medical radiation in any form are: will the test lead to a better treatment and outcome? Would you get that treatment without the test? Are there alternative imaging tests that don't involve radiation, such as ultrasounds or magnetic resonance imaging? When a CT scan is necessary, how can radiation exposure be minimized? The Voice of Russia also posted an article titled "Nano Treatment to Replace Radiation and Chemotherapy." What nanotechnology does is that it provides a way to deliver specific drugs to specific cells using nanoparticles. Since it is difficult to track a certain group of cells, experts have come up with a solution known as quantum dots. Quantum dots are really tiny pieces of material. You can basically inject quantum dots into the body, and if they are properly functioned, then they can attach to certain biological objects. For example, they can attach to cancer cells and kill them to leave the healthy cells alone. Downside to this is that quantum dots are usually made out of toxic elements. Fortunately, experts are studying very small particles known as exosomes, which are released from all cells, transferring small amounts of genetic information. This plays an important role in figuring out how cancer cells work and behave, possibly leading to a cure.